Hello, and welcome to the frontier of physics. Today, we are exploring one of the greatest unsolved mysteries in the entire cosmos. A mystery that quite literally determines why you, me, and everything we see exists at all. We are talking about the epic battle between matter and antimatter. Think of it as the ultimate cosmic rivalry. A mirror image of creation, where for every piece of our familiar universe, there exists an opposite, a perfect twin. But this twin has a terrifying power. When it meets its counterpart, they annihilate each other in a flash of pure energy. So, if matter and antimatter are perfect opposites, and they destroy each other on contact, why is there a universe made of matter left behind? Why does anything exist? This is the story of that mystery. Let's begin. First, let's make sure we're all on the same page. What is matter? You already know it well. It is everything you can touch, see, and feel. The screen you're watching this on, the air you breathe, and even you yourself. At its heart, matter is made of atoms. And atoms are made of even smaller particles. Protons with a positive charge, neutrons with no charge, and electrons with a negative charge, whizzing around the nucleus. For our story, the most important player here is the electron. Remember that. Now, enter antimatter. Its story begins not in a lab, but on a piece of paper. In 1928, a brilliant physicist named Paul Dirac was trying to reconcile the laws of quantum mechanics with Einstein. Special relativity. His equations worked beautifully, but they had a strange, puzzling quirk. They predicted that for every particle of matter, there must exist an opposite particle. A mirror image. At first, Dirac and others thought this might just be the proton, but it didn't fit. The math was clear. This mirror particle had to have the exact same mass, but the opposite charge. 4 years later, in 1932, a physicist named Carl Anderson proved Dirac right. He was studying cosmic rays, high-energy particles from space, when he saw a track in his cloud chamber that could only be one thing, an electron, but with a positive charge. He had discovered the antimatter counterpart of the electron. He called it the positron. It was real. Dirac's prediction in the mirror was confirmed, and he would later win a Nobel Prize for his work. So, what exactly is antimatter? Think of it as the perfect opposite twin of matter. For every matter particle, there is an antimatter particle. We have the electron and the positron. We have the proton and the antiproton. We have the neutron and the antineutron. The rules are simple. 1, they have the exact same mass. 2, they have opposite electrical charges. So, an electron is negative, a positron is positive, a proton is positive, an antiproton is negative. But there are other, more subtle properties that are also reversed, like what we call spin. For our purposes, just remember, they are perfect charge, reversed, mirror images. And when these perfect opposites meet, that is where the magic and the danger happens. They don't just bump into each other, they don't create a bigger particle, they vanish. In an instant, the combined mass of both particles is converted into pure energy, following Einstein's most famous equation, E equals mc squared. This process is called annihilation. It is one of the most efficient and powerful reactions in the universe. A single gram of antimatter annihilating with a gram of matter would release an explosion equivalent to about 43 kilotons of TNT, roughly the size of the atomic bomb dropped on Nagasaki. This isn't just science fiction. We use this principle in medicine today. PET scans positron emission tomography work by injecting a radioactive substance that emits positrons into your body. When those positrons meet electrons, they annihilate, creating gamma rays that are detected to form a detailed image of your insides. So, antimatter is real, it is powerful, and it is among us. Now, let's go back in time, to the very beginning, the Big Bang. Our best theories tell us that the universe began in an immense fireball of energy. As it expanded and cooled, this energy condensed into particles. And crucially, the laws of physics suggest that matter and antimatter should have been created in perfectly equal amounts. For every quark, an antiquark. For every electron, a positron. The early universe was a super dense, super hot soup of particles and their antiparticle twins, and immediately they began to find each other. Annihilation on a cosmic scale. This should have been the end of the story. All the matter and all the antimatter should have completely annihilated each other, leaving behind a universe filled with nothing but a dull, fading glow of light, a universe of radiation, with no planets, no stars, no life. But you are here. You are watching this. So clearly, that is not what happened. Something went wrong, or from our perspective, something went very, very right. Not all the matter and antimatter annihilated. For every billion particles of antimatter, there were roughly 1 billion and 1 particles of matter. After the Great Annihilation, after all those titanic clashes, that 1 in a billion particle of matter was left standing. The rest was just ash. That tiny, tiny imbalance, that 1 extra piece of matter in a billion is all that we are. Every galaxy, every star, every planet, and every human is made from that 1 part in a billion left over. The greatest mystery in physics is what caused that imbalance. Why was the universe not perfectly symmetrical? Physicists call this baryon asymmetry, or CP violation. And we are still searching for the ultimate answer. We have found a few clues. The first breakthrough came in 1964. Physicists James Cronin and Val Fitch were studying particles called kaons, which are strange mesons made of a quark and an antiquark. They discovered that these particles and their antimatter counterparts did not always decay in exactly the same way. This was huge. It was called CP violation. It proved that the laws of physics are not perfectly symmetrical for matter and antimatter. There is a tiny, built-in bias in the universe. This was a Nobel Prize-winning discovery, and it gave us a possible mechanism for the matter-antimatter imbalance. But there is a problem. The amount of CP violation we have observed so far is far, far too small to account for the 1 in a billion surplus of matter we see in the universe. It is like finding a single fingerprint at a crime scene, but the print is too smudged to identify the culprit. So, the search continues. You might be wondering, if antimatter is so rare, how do we even study it? We make it right here on Earth, at places like CERN, the European Particle Physics Lab. We can create antimatter in particle accelerators. By smashing particles together at near light speed, we can convert energy back into matter and antimatter pairs. Just like in the early universe, but creating it is only half the battle. How do you contain something that annihilates the moment it touches normal matter? The answer is, as brilliant as it is sci-fi, we use magnetic traps. Since antimatter particles like antiprotons and positrons are charged, we can create powerful magnetic bottles to levitate them, holding them in a perfect vacuum. Suspended away from the walls of the container, we've managed to store antimatter for months at a time, allowing us to study its properties with incredible precision, looking for any other tiny differences between it and matter that could solve our cosmic mystery. So, where does that leave us? We know antimatter exists. We know it is the mirror of matter. We know they annihilate. And we know that a profound asymmetry in the early universe allowed a tiny residual amount of matter to survive and form everything we know. But we still don't know why. The answer lies somewhere in the fundamental laws of physics, perhaps in the first fleeting moments after the Big Bang. It might be tied to neutrinos or to particles we haven't even discovered yet. It is a puzzle that drives some of the biggest and most expensive experiments in the world. The battle between matter and antimatter is the reason we are here. It is the ultimate question of our existence, and the search for the answer continues at the very edge of human knowledge. Thank you for joining me on this journey into the heart of this cosmic mystery. If you enjoyed this exploration, please like and subscribe for more journeys to the frontier of science. Let us know in the comments, what do you think is the answer to the matter-antimatter mystery? Until next time, stay curious.